So this talk is it's an important discussion that's been happening the last, it's about an important discussion that's been happening the last 2 or 3 years, but it's also very personal for me because I've done many things, but in large part I've made a career of building open source software. I'm now in my 9th year of building open source, and so I would say this talk has more questions than answers, but these are the things that I think a great deal about in terms of how we produce open source software and how we can better support open source developers. So I guess a subtitle for the talk would be community-led open source and you. And I will explain what I mean by community-led open source, and we'll dig right in. So, having a nearly decade-long perspective on looking at the open source world, it's pretty amazing all that has happened. GitHub is 10 years old this year, which is kind of mind-boggling when you think about the way that open source developers collaborated 10 years ago. I mean, people used to literally send around patch files, and then they would send code reviews in the form of comments on patch files in email form. So it's become easier than ever to start new open source projects and to collaborate and to make really interesting things happen through the synergy of bringing people together in a very lightweight way on GitHub. And open source has had a really major role in the development of what we now can call the modern data science stack. And it's really interesting to think about what might have been in the field of data science were it not for all of the open source projects that developed in the Python world, in the R world, in the Apache Hadoop ecosystem, the Spark world. But it's interesting because one didn't exactly cause the other. Some people are like, well, maybe open source projects precipitated the rapid growth of the field of data science, or maybe the other way around. But the reality is a great deal more complicated than that, and it was really this kind of symbiotic relationship in that people are collecting and analyzing more and more data. They need software to analyze that data, and the open source community miraculously was able to rise to that need at a critical time. So a big part of that is the collaboration and code reuse aspect, where you can kind of pick your cliche, whether the best code is the code that you don't have to write, or great artists steal, or I'm sure there's many other such aphorisms about reusing code, but the fact that permissive licensing allowed projects to be able to cut and paste code in a safe way and build new projects, and to be able to bootstrap themselves off the work of others in a very rapid way helped progress happen very, 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 very fast. Obviously, with the rise of the mobile and social web, companies scrambling to get more people to click on ads and instrument their apps to collect extraordinary amounts of data, needed software to be able to collect and manage and analyze and visualize and produce models to act on all of that data. And they just needed to scale so fast that they couldn't wait around for commercial software vendors to build software to solve those problems. And so that's why you saw Apache Hadoop came out of Yahoo back when Yahoo was still a thing. Facebook was the original creator of Apache Hive, for doing SQL on Hadoop. Sort of many of the big internet companies, created these, what became really important open source projects, because they had to work really fast to solve the problems that were right in front of them, and they felt that releasing those projects as open source would help the progress and innovation happen faster than it would otherwise. Another factor that I think a lot about is the interplay between closed source licensing models and cloud computing. So it used to be that you would have a server room, and whatever's in the server room, you'd have to call up your IT guy, say, hey, your IT person. So you call up your IT person and say, hey, we need to buy some more server racks to increase our ability to do workloads. But with AWS and cloud computing, you can very easily go from 10 nodes to 100 or 1,000 nodes. And can you imagine if you had to call up the MathWorks or call up SAS Institute and buy a bunch of licenses to be able to scale up your analysis in the cloud? So having open source software to be able to, at your own, kind of your own free will, kind of install as much of the software as you want without having to, in a friction-free way, I think was a big factor in driving data science to open source. Another major factor is just problems with reproducible research results in science, and there have been now at this point many high-profile cases where there were errors made in analyses, whether it was an Excel error causing some part of the subprime mortgage crisis, or different kind of problems reproducing major results that impacted public policy or impacted decisions in medicine or other areas. And so in academia and in science, in research labs, there's been a push to increase transparency and to make as much of the science completely reproducible, whether it's here's a Jupyter notebook which has everything from top to bottom. Here's how I got the data. Here's how here are the libraries I used to load and pre-process the data. Here's my model. Here's my results and my data visualizations. And so I do hope that we see more and more in that there's this social expectation in science that you want to publish an analysis. Where's your Docker file? Where's your, where are your data files? How can I, reproduce your results, myself, and see, maybe you cherry picked, or you had, problems with your analysis that make your results less compelling. Another major trend that's been a side effect of the growth of open source is the challenge with making open source software work in the enterprise. And you could argue that this is a major reason why all of us are sitting here in the house of Domino Data Labs, kind of one of many companies who are helping make open source work in big companies. It's like, oh, we need all of these tools to enable governance and collaboration and auditing. And what if somebody does a bunch of research and then they quit? Like, where is all of their work, and how do we keep track of that? So there's all these problems that happen in big companies, and in large part, open source developers, these are not the types of problems that that many open source developers would solve on their own, kind of in their free time. Particularly when you consider kind of where a lot of the open source developers are and what kind of problems they're trying to solve themselves. So it's kind of with all of this in mind, like, I think a lot, and I talk to a lot of companies about just thinking more about where the software comes from. So who builds it, who are the individuals who wrote the code, who's maintaining the projects, who's managing the flow of code from outside contributors, people making pull requests on GitHub, who decides what code ends up in the master branch on GitHub, who's managing releases. Essentially, how is the sausage made? And it's one of those things where, the more it's kind of like, the meat industry. The more you learn about, the meat industry, the less you want to eat meat. And the more you learn about open source software, well, I'm not sure what would be the right analogy, but the more you learn, the more concerned you get about how it all comes together. And a part of it is, who paid for it? So, it's like, if somebody spent time on the project, were they being compensated for that? Was it their nights and weekends? So I'm just going to put some air quotes around the paid thing, because this ends up being a complex subject. And there's many kinds of open source projects, and so not every open source project is created equal. And I don't know what are the right words to describe these projects, but I kind of broadly, and this is an oversimplification, put put the projects into two different buckets. So industry or corporate-led projects and community-led projects. So industry or corporate-led projects typically are projects that were started by a single company or perhaps a small consortium of companies. Sometimes the code base started out as a proprietary code base that was open sourced later, whenever there was like a market need, or maybe an open source project came along that threatened that proprietary project, and then they decided to open source it. Maybe the project was conceived as an open source project from the get-go. And so, a great example of this type of project is TensorFlow from Google, where TensorFlow is being used internally at Google, and just in terms of as part of Google's plan to rule the world, they felt that having everybody use TensorFlow for machine learning and deep learning and making it easy to use on Google Cloud was part of their development strategy. Community-led projects are different. Sometimes they have very diverse origin stories. Sometimes they're started by ambitious individuals with an itch to scratch or some kind of vision. So I put myself into that category. Some of them are started by people in research labs, whether government-funded research labs, like scikit-learn for Python has been sponsored by government-funded research in France and many other things, but that's where it got started. Matplotlib and a number of other Python projects were sponsored by different government research programs. Sometimes the work has been done in universities. When you look at the R world, the initial R world came out of kind of indirect support from statisticians wanting to build free alternatives to the S programming language, which was proprietary. And so it's interesting because in any different in any different ecosystem, you might have a higher composition of community-led or kind of projects that came out of organic growth, or projects that were led by a company with a particular agenda. One of the challenges, and there are many challenges that come up, is you think about what incentivizes software developers to create high-quality software. So in the case of open source projects, often will face criticism about the level of professionalism in their projects, whether it's issues with packaging, issues with documentation, issues with testing, packaging, continuous delivery. There's many different problems, and I find that in community-led projects, a lot of the kinds of things that people think about in terms of professional enterprise-grade software engineering goes by the wayside. And the problem there is that the incentive structure is just not there to support that work. When you can choose between adding new features and maybe fixing some critical bugs, there's a lot of different kinds of work that would be really great to do if we had infinite people and infinite resources, but it's work that goes by the wayside. Whereas if you have a commercial software project or even industry-led, let's say you consider TensorFlow versus all of the other kind of competing AI frameworks led by kind of Facebook, Microsoft, kind of the other major tech companies. They have an incentive to make make TensorFlow, or for Facebook to make PyTorch, to make the most professional, the best documentation, the best testing, kind of the most the software that people can put their trust in. But it is not always so easy for a project to do that, given their level of resourcing. Another thing that's complicating this for people who build data science or data processing projects in particular is that, with the way that things are going in the world, with kind of all of the issues around, data privacy and just, having trust and transparency in the software, is that more and more there's the expectation that if you are going to build a data science project, you want all of the software that you're using to be open source, so that you can, if you need to, you can look at how it's implemented and understand it. You can see if maybe your data is being used inappropriately in some way, and if you were sending sensitive data into a black box that you don't know anything about, that could create some concerns. And so, for people like me and people who build open source software for a living, the fact that we might like to kind of build more closed source software to be able to generate revenue to support our work, but in many cases, people don't want a lot of the software to be closed source or to have a business model associated with it because of these issues around trust and transparency and the freedom to reuse the software and to make changes. I mean, no type of project is free of problems. So you do see issues in projects that are led by a single corporation, or that are primarily led by kind of a single company or multiple companies. You will see projects change. You will see companies change strategy and basically abandon projects, or move the developers to another team. If a startup is building an open source project, you may see that startup get acquired or that startup fail, and the project gets similarly abandoned. And there's other problems that can occur there. The problems that occur in community-led projects are a little bit more insidious and concern issues around developers and maintainers burning out because there isn't enough support to enable them to keep up with the work of building the project. And these problems become worse the more popular a project gets. And so you would think that the more users you have, the more maintainers and core developers you have. But in my experience, this isn't really true. I mean, you do get more core developers, but it's not a linear growth. You would think with a project like Pandas, which has millions of users, that we would have 100 core developers or maintainers, kind of making the project work. But really, it's in the single digits. It's under 10 people who are kind of slaving away, making the project work on a week-to-week, month-to-month basis. And a part of this is that the circumstances that enables an individual to be a maintainer of a project or a core developer, where they're spending 50% or more of their time, turn out to be very special and are there are situations that are difficult to come by. So recently there was a tweet that went viral. This even slides a little bit out of date, that kind of in analyzing the Pandas project, the NumPy project, and the Matplotlib project, if you look at who's actually at the bottom of the funnel, who's managing the code that goes into the project and is making the project work, it's a shockingly small number of people. And so the caption was, we rely on 15 people to do our science. Without them, these projects would basically would not be maintained. So this is the kind of stuff that keeps us up at night, while we have a huge number of the long tail of contributors has grown immensely, and we've had over 1,000 unique contributors to Pandas just alone. But the actual number of people that are really making the project work is a shockingly small number of people, and it's a number that's not growing very fast. This is complicated also by the relationship between users and developers, which can also grow quite toxic. Particularly the more popular a project becomes, we have found kind of anecdotally that the users stop thinking about the people producing the software as people. They're just kind of, they just assume that the software exists and it is built to their level of satisfaction. There was an exchange with a user on the Pandas mailing list some time ago, and he described himself with the word customer. And I had to kind of stare and sort of try not to overreact, and I was like, well, I'm gonna take a break and not reply to this email for a little while. And I did end up replying in a more civil tone, but I think my initial reaction was, "Sir, I believe you are mistaken." So there are a number of myths that surround these community-led projects. So one is this idea of organic growth and organic contributions, that if you want to see progress and innovation in project, many of you, I'm sure in your companies, you didn't use, all of these open source projects that you use now, you weren't involved in the creation of them. Like, you started using open source at some point, you're like, oh, well, what should I use? Okay, I'm going to conda install all of these things, or, install .package all of these things. And so if you want things to get better, maybe all you have to do is wait for the organic process of open source to make things better, kind of, it magically sprang forth out of the earth. But I find that the process of building this software is not very random and, frankly, not very repeatable. So the types of people who are gravitating to work in the Python ecosystem, work in the R ecosystem, are quite different from the people who were attracted to the ecosystem 10 years ago when things were not popular, when there was a feeling of greenfield development and forging new ground and kind of building something from nothing. So it's, the process that generates software now is quite a lot different. Another problem that I see is this idea that burnout is not kind of an exaggeration or not as big of a problem as it's reported. So the idea that if maintainers or developers burn out, it will be okay because if they burn out, other maintainers will spring up as part of the random process to replace them. And so that may be that if some core maintainers burn out, that other people will step up into a leadership role. But more often than not, they would be stepping into a role that was already overburdened, and so they will find themselves in the same situation that was causing burnout in the first place. And so really, what we've got to figure out is how to have 5 times as many core developers and maintainers in these projects. Another issue I think comes from the attitude of enterprise software engineering, where engineers really are thought of as fungible assets, and you would be remiss to plan a software project that has a bust factor of 1, or if this person leaves the company, this whole project is going down the tube. So we need to be able to be resilient to people entering and leaving a project. And it is true that many enterprise projects, compared with open source projects, they may be more straightforward, like building a website or building something that has a very kind of well-defined plan of how to build it. Whereas open source projects that are building something new and innovative requires a different type of engineer to really drive forward. So, the sad reality, and this is some data that the company Tidelift collected, that a lot of open source work today has no funding, or people are being funded maybe 20% of their time to work on community-led projects, kind of as part of their work. But even that can be complicated. So another problem here is kind of the breakdown between kind of maintenance work and innovation work in open source projects. That projects start out with kind of this rapid innovation and change, and at some point when they become very popular, the maintainer, the core developers turn into maintainers, where they are essentially treading water to maintain the status quo, and that also can be a source of overburden and burnout for the developers. So this was brought to fore a couple of years ago, maybe it was 3 years ago, and the Ford, Nadia Eghbal and the Ford Foundation wrote this report called Roads and Bridges: The Unseen Labor Behind Our Digital Infrastructure. And it talked about the Heartbleed bug in OpenSSL and a number of other projects. And a lot of people were shocked, that how under-maintained OpenSSL, such a key component in how the internet works, could have shocking bugs causing people's secure information to be exposed to malicious parties on the internet. And these were the kinds of bugs that could have, if there was more rigorous testing and fuzz testing, these were problems that could have been identified in the project if sufficient effort were put in. So one thing I don't hope to convince you of this, but I believe it, is that community-led projects are very important to you. You may use a lot of projects that are produced by one of the major tech companies, but the way that community-led projects operate is different and gives you more of an opportunity to impact the roadmap and direction of the project, to make meaningful contributions and to help drive them forward in a way that is beneficial to your future work. So developers do try to find ways to fund their work. The major ones are to find a corporate benefactor, and that can fail in some ways if kind of that benefactor decides that they would rather have you work on a different project and not reward you for your open source work. Developers will do consulting to support their work, and that creates a tension. I've done this as well. It creates a tension between hustling for consulting contracts to pay your bills and spending time on the underlying open source, which is kind of driving the consulting work. And my experience has been that you end up not having enough time to focus on the underlying open source project. I've been very involved in the last couple of years with the Apache Software Foundation. I just became a member earlier this year, which is quite prestigious. But I'm a big fan of the Apache Software Foundation because it provides a framework for corporate-led or industry-led projects to bring community governance and community process to projects that might otherwise be dominated by a single organization. So projects that maybe didn't start out as community-led can become that way by adopting the Apache process and joining the foundation. So there's kind of key principles that the ASF operates by around how decisions are made in kind of an open and transparent way, that we operate on the basis of consensus, that we allow people to gain influence in a project through making contributions. So there's a very straightforward way. If you want to become influential in a particular Apache project, you can do that through making contributions to the project. And in many projects, particularly if a project is run by, if you wanted to go and make major changes in TensorFlow, I think you would, in a lot of cases, you would need to work for Google to be able to make major changes to TensorFlow. Whereas in a community-led project, if you contribute a great deal and gain influence in the project, you can get a seat at the table and be a first-class developer. I do worry that maybe we're at this critical point and things could go one way or the other, that maybe all the community-led open source projects will fade away, and the new model will be that all of the open source is produced by top 10 tech companies. I mean, it's actually a pretty realistic future possibility that open source developers say, we can't get anyone to fund our work, and really it's only Google and Facebook, Microsoft, and Netflix and Amazon, are going to be the ones to produce the open source software that we use. That prospect does make me a little bit sad. There's the movie Demolition Man in 1995, where it's like now all restaurants are Taco Bell. So I hope that doesn't happen to open source software. But I know I'm running out of time, but I'll take maybe three more minutes of your time. But there are ways that you can help. The two major ways that you can help make things better for open source developers. So the first is giving your time. So if you have engineers who have a project that they use, they want to contribute to, they're passionate about, to give them the time to do that. Not only to give them the time, but to reward their work and their contributions to that project equally to their work building projects that are internal. A problem that I've seen is that sometimes people say, hey, you can work on this open source project, but there's this really important project that's important to the business. So you can make your choice, but this project's going to get you promoted, and this open source stuff, well, it's at your own risk. So don't do that. Another way is to, if you don't have the engineers to make contributions, is to give money. Turns out that giving money to open source projects is complex, and just knowing where to give the money, in the Python world and beyond Python, but starting out in the Python world, there's a new organization in the last few years, NumFocus, which has provided a financial conduit for donating money to support projects like Pandas, and that's helped us to do quite a lot of things. I've just created a new organization called Ursa Labs to raise money to do development in Apache Arrow, oriented at the data science world. So I've been working on the Arrow project for the last 3 years or so, and we're at an inflection point where we really need to build a larger and dedicated team to build out better computational infrastructure for data science. So I think over the next few years, we'll see more organizations like this that provide a more straightforward conduit for money from organizations that have it to teams of people where we can put people to work working full-time building open source software. So a last thing, since I'm completely out of time, they're going to kick me off the stage, is that there are many success stories and proof that even small amounts of funding and that individuals can make a great impact. I really love this story from Nathaniel Smith, who's a longtime Python developer. He was funded by Berkeley BIDS for 2 years to work on NumPy and a number of other Python projects. And working by himself for 2 years with a very modest amount of funding, I think he could have made more money working for a tech company in downtown San Francisco, but he chose to work for Berkeley BIDS because that was his passion. And he alone was able to make big contributions in this space. And I think we kind of dream about what might be possible if we were able to do 10 times as much as we've been able to do in the last 5 years. So thanks for your attention, and thanks for using open source.
So thank you very much for the talk and for the great work. So my question is, do you think, I see a lot of companies now they have developer advocates where they work on open source projects. Do you think that's a way to help the open source community on, keep maintaining all the software and all the work?
I think it does. I mean, I think when companies that contribute to open source projects, it goes beyond just charity. I think there are other benefits in building your company's technology brand. So it's it's part kind of feel good. We're making the open source world better, but it's also marketing for your organization that you're doing good in the world and you're supporting these projects. So it's it's sort of a win-win. And I think that developer advocates, just in terms of lobbying for, because engineers who want to contribute to open source projects may not be the best advocates for themselves, and kind of arguing to management about why they want why those contributions matter, and that it will make them happier and make them kind of less likely to churn and kind of move to a different company. So I think the developer advocates do help a lot.
So with how long some of the, take Pandas as an example, it's been developed for years. And I've talked to some people who've expressed interest in doing open source stuff, but they don't actually know how to get started with how much upstart time there might be in things like this. Do you have any advice on how to get started helping with these types of projects?
Yeah, I mean, it varies from project to project, how easy it is to get started. I know in Pandas in particular, we try to we try to curate the issue tracker and identify work that will be accessible to newbies to help people get started. There are hackathons, kind of there was a there'll be hackathons or sprints at conferences. That's a great place where you can go and meet the developers who are involved in these projects, and often the sprints or the hackathons will be oriented at helping onboard new contributors and helping people write their first pull requests. So recently we had a worldwide documentation sprint for Pandas, which yielded, hundreds of pull requests in a 24-hour period. And so I think it helps to have some kind of mentorship, or at least engage with the development team. And I always tell people, if they aren't sure where to start, reach out on a mailing list, or kind of, if you find an issue that looks interesting, to just ping the developers and say, hey, I'd love to work on this, and how can I get started? And I think it varies from project to project. So maybe the Linux kernel might be a little bit hard, but I think a lot of projects are generally welcoming and are I think would like to help people make their first contribution and get involved. Even small contributions. There's no contribution too small.
Thanks, Wes.
All right, thank you.